Hello class, this is Mr. Eggleston, and this is Algebra 1, Unit 7 Quiz Review. The first question, consider the function given by y equals x plus 5 quantity squared minus 13, and it says identify the vertex of the parabola. This is the vertex form of the equation. So it's easy. Remember, your x is a liar, so your x value of the vertex, or your axis of symmetry, is going to be x equals negative 5. The y value of the vertex is going to be negative 13. So the vertex of the parabola is going to be at negative 5, comma, negative 13. And there you go. Identify the axis of symmetry. Well, I just did right here. It's the x value of the vertex. All right, easy peasy. Second question is talking to graph this equation in vertex form. All right, looking at this, you know where the vertex is. The vertex is going to be at, negative 2, comma, negative 2. Remember, your x's are liars, so that's the x value of the vertex, and this is the y value. So the vertex for this is negative 2, which is right there. And then we know that when we can just use the pattern, you start at the vertex, move over 1, square it, that's 1, you go up 1. Notice I know we go up because the sign in front of the squared term, the x plus 2 squared, is positive, so we know it goes up. Here's my axis of symmetry. Okay, there's my vertex. Over 1, 2, 2 squared is 4, up 1, 2, 3, 4. Over 1, 2, 2 squared is 4, up 1, 2, 3, 4. And that's your parabola. You just connect it with a U as neatly as you can, like that. Okay. A little ugly on the back end, so I'll just erase this. And that's good enough. All right. And that's question number 2. Just strictly, here's the graph in vertex form, graph it. Then it says, this is a thinking question. Okay. It says the graph of a quadratic function f is given. The coordinates of the vertex of the graph are a, comma, 36. Okay, we don't really need to know the y value. It's nice to know it's 36, but we don't know what the x value. This is the axis of symmetry. Now, we know the axis of symmetry is exactly in between any two given points that have the same output value. Usually we talk about the intercepts, but in this case, we're going to use the fact that we know that when x is 2, the output's 20, and when x is 10, the output's 20. They have the same output. So we're looking right here, and if we find the average of these two x values, the average will put us right in the middle, and that'll give us the value of a. So a would simply be 10 plus 2 divided by 2, or 12 divided by 2, which equals 6. So we know the axis of symmetry is at 6. All right? So we know a is 6. Not that they asked you specifically for what a is. They just wanted the equation of this of symmetry. Okay? So, I'm sorry, I'm just trying to... So it would be x equals 6. But what we do know is that this point 10, comma 20, it's 4 units to the right. So this comma point here, 2, comma 20, is 4 units to the left. In other words, 6 plus 4 is 10. And 6 minus 4 is 2. So it says find the coordinates of both So they want us to find the coordinates of both x-intercepts here and here. Well, one we see, it's at 0, 0. So we know the coordinates of one x-intercept is 0, 0. We know that this is 6 units to the left, so there's a sister point 6 units to the right. So 6 plus 6 is 12. So this point right there is 12 units to the right. So it's 12, 0. That's symmetry. And then they're asking you if f of 4, if that's 6, 4 would be somewhere right around here. And that point is 32. They want to know which other value of x does f of x equals 32. So we know 4, so we know this distance right here is 2, so the sister point would be 2 units to the right. So that would be x would equal 6 plus 2, which is 8. So we know f of 8 equals 32. All right? And that's all symmetry. I love these questions. The next question has a little typo. I fixed it. That's not supposed to be h of k. That's supposed to be h of x. So it says the equation for a function h is given. Boom, right here. 1/9 x minus 6 squared plus k for some constant k. The graph of y equals h of x is shown. Here's the graph right here. And find the value of k. Well, k, this in vertex form is the y value of the vertex. Remember, the vertex, when it's written like this, the vertex is going to be h comma k. So in this case, it's going to be 6 comma k, because we don't know what k is, but it's the y value, and there's our vertex. The vertex occurs at 6 comma 1, so we know k must equal 1. Easy enough is to flip this and say, and give you this, and ask you what h must be in this equation. All right? That's another way of doing it. Now, it says let g of x, number 5, let g of x equals 4x squared minus 10, and h of x equals x plus 2 times x minus 4. Which function's graph has an axis of symmetry that is further to the right? Well, looking at g of x, so this side will be g of x. We know that the axis of symmetry, when it's written in standard form like this, is going to be x equals the opposite of b over 2a. So that's going to be, but remember, b's the number in front of the linear term. There is no linear term. Matter of fact, this can be thought of as 4x squared plus 0x minus 10. So what you have to realize is that b is 0, not negative 10, which some kids might say. So this is going to be the opposite of 0 over 2 times 4, which is 0 over 8, which is 0. So the axis of symmetry is at x equals 0 for g of x. H of x, we're going to have to find the zeros. Well, the zeros are what makes the two factors 0. So we said x plus 2 equal to 0 and x minus 4 equal to 0. X equals negative 2 and x equals 4. So the axis of symmetry for this is going to be x equals, now we find the average of negative 2 plus 4 divided by 2. That's going to be 2 divided by 2, which is 1. So h of x has a axis of symmetry at x equals 1, which is like right here. And then g of x, it has an axis of symmetry at 0, which is to the left. So that it tells you that h of x has an AOS further to the right. Because 1 is greater than 0. Okay, now, next question. Question 6 harkens to 7.0. or excuse me, 7.1. The first section talking about sequences and linear growth and arithmetic growth, geometric growth, and quadratic growth. Is it possible for this sequence to be arithmetic? To check that, we take our three values, and 29 minus 22 is 7. 36 minus 29 is 7. And you notice the first difference is constant. Okay? So yes, this sequence is arithmetic. The fourth term would be 36 plus 7, which equals 43. So is it possible for this sequence to be quadratic? No, because the first difference is constant. Okay, this because first difference is constant. I already told you it's arithmetic. They're kind of mutually exclusive. One, you can't have both. If it's arithmetic, then it can't be quadratic. If it's quadratic, it can't be arithmetic. All right, on number 7, it says write y equals x plus 5 times x plus 8 in standard form. That means multiply these out. And I showed you in class the best way to do this is to draw a little box where you write each factor, one across the top and one down the side. We have this, and you multiply. X times x is x squared, x times 5 is 5x, 8 times x is 8x, and 8 times 5 is 40. And then you add up all the terms inside. So y would equal x squared, because that's by itself, and then 5 plus 8 is 13x plus 40. And that's the answer. That's the product of x plus 5 times x plus 8 this is standard form. Okay. On 8, it says let g of x equal x minus 15 times x plus 9. Find all solutions to the equation g of x equals 0. Well, that means you said each factor equal to 0. X minus 15 equals 0. And x plus 9 equals 0. X equals 15 or x equals negative 9. It's real simple. You just set each of these linear factors equal to 0 and solve for x. All right, so that's the answer. Okay, question 9, solve w squared minus 10w plus 1 equal to 40. To solve quadratic equations, we have to have it equal to 0, so we'll subtract 40 from both sides. And we have w squared minus 10w minus 39 equals 0. Now, there's lots of ways to solve this. You could use the quadratic formula, or you could use factoring if you know how to factor this. I think I'm going to try factoring. What two numbers multiply to negative 39 and add up to negative 10? Well, negative 39 could be 3 and 13. One of them's got to be negative, and it's got to be the bigger number because the sum, remember this is the sum down here, is negative 10. So it looks like it's 3, negative 13. So this can be thought of as w plus 3, w minus 13 equal to 0, which gives us two answers. W equals negative 3, and w equals positive 13. All right? So there you go. That was by factoring. You could also use the quadratic formula. But I'm not really, well, here we go. I'm going to do it x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You could also have done it this way, where b was negative 10, so the opposite of negative 10 is 10 plus or minus the square root of negative 10 squared, which doesn't really matter because it's squared, the negative sign goes bye-bye, minus 4 times a of 1 times c of an ugly negative 39. Okay, all over 2 times 1. So this equals 10 plus or minus. Now, using our calculator, 110, negative 10 squared is 100. Negative 4 times 1 times a negative 39. So 4 times 39 is, you add that up, that's 256. So it's the square root of 256 all over 2. Square root of 256 is 16. So it's 10 plus or minus 16 over 2, which equals 26 over 2 and negative 16 over 2, which equals 13, comma, negative 8. I'm sorry. Negative 10 minus 16 is negative 6 over 2, which is negative 3, which are the same answers we got by factoring. I think factoring was a lot easier if you could handle the numbers. Okay. Question 10 was, okay, now a function g is given by g of v equals 6v plus 11 times v plus 13. Find the zeros of g. So we have 6v plus 11 equal to 0 and v plus 13 equal to 0. So we got to solve both. This one is probably the little bit uglier one. Subtract 11 divided by 6. V equals negative 11 divided by 6. This one was just subtract 13. And here you go. Okay. Easy when it's given to you in factor form. You just said each factor equal to 0 and solve. Which expression is equivalent to x squared minus 7x minus 18? You got two ways of handling this. You can either multiply out all of these, a, b, c, and d, or you can factor the trinomial. What two numbers multiply to negative 18 adds up to negative 7? Well, I hope you guys know that's negative 9 and 2. So it's x minus 9, x plus 2. Obviously, it's not that one because that's the reverse of the signs. This one has we don't have 6 and 4 or 6 and 3 nor 3 and 4, but we do have a positive 2 and a negative 9. The answer was D. All right, 12, 13, and 14. Here we go, the last little bit. The graph of a quadratic function p has x-intercepts at x equals 9 and x equals 7. Write two possible equations for p of x in intercept form. Well, equation 1, you could just write this as x minus 9 times x minus 7. That's 1. And since you can change the number in front of the stretching factor, to be anything you want, another one would be negative 2, x minus 9 and x minus 7. How many possible graphs exist with these two x-intercepts? An infinite amount. Because you can change a to be anything. It's a stretching factor. The idea is this. Let's say it was 9 here, and let's say you had 7 here. You could have this as a parabola. You could have that as a parabola. You could have, stretched way up high, like that. All of these are parabolas. You could also have it stretched way down low like that. So you can just keep drawing an infinite number. An infinite number. Okay? Now, it says the graph of a quadratic function, G is shown. Notice the graph includes the axis of symmetry of x equals negative 3.5. So we know that one x-intercept's over here at negative 9. So one of the solutions is x equals negative 9 because it's given to you. And you can figure out that negative 9 is to the left of negative 3.5. So it'd be negative 9, or it'd be 9 minus 3.5. What? Negative, oh, come on. Oh, what the heck? Negative 9 minus 3.5. So this distance is 5.5. So we add it to this side, 5.5, and that's going to be, the other one's going to be negative 3.5 plus the distance of 5.5, which is, I believe, 2. So this is 2. And those are the solutions. X equals negative 9 because it was given, and x equals 2, and we got that from that concept of symmetry. All right? Now, lastly, find the solutions to x squared minus 13x minus 8. Well, my first thought is try factoring, because I always think factoring is the easiest. What multiplies to negative 8 adds up to negative 13. There are no numbers that work, so it's not factorable. Okay, you can't do this. The other option is the quadratic formula. Now, I know the book or our curriculum, and I showed it to you in class, but that's not how I learned the quadratic formula. I learned it as x equals opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And then you just plug in what a, b, and c are. So b is negative 13. The opposite of negative 13 is 13, plus or minus the square root of b squared, which would be negative 13 squared, minus 4 times 1, that's a, times c of negative 8, all over 2 times 1. Well, this equals 13 plus or minus. I know off the top of my head that the square root or 13 squared is 169 plus 32 all over 2. I'm doing this without a calculator. I better be careful. 69 plus 32 is 201. So the exact answer is 13 plus or minus the square root of 201 all over 2. And that would be the two solutions from the quadratic formula. Okay? And that's it. I'll come back with a second video doing this with the equation they actually give in the notes for the x-intercepts, because it's not this. This is your traditional quadratic formula that has been taught throughout the ages, quad formula, not the little thing that they showed you, even though it works, okay? So have a good day.